So good afternoon. My name is Grant Ellington. I'm with the Biological and Agricultural Engineering Department at NC State. What I want to do is just give you a real brief overview of some work we're involved in this past year, looking at on-farm hemp drying and also two preliminary drying studies we're involved in. And this work involves myself and also Kyle Bastian, who's an extension assistant in the Biological and Agricultural Engineering Department at NC State also. So many of the existing tobacco locations we're already at collecting performance information associated with curing tobacco. Those farm operations are also grew hemp for CBD oil extraction in 2019. And once again, we're primarily on farm collecting performance information associated with curing tobacco. And so the material has been dried in the bulk curing barns. We call them bulk curing barns, but they're actually crop drying pieces of equipment. They have a tremendous amount of airflow capacity, and they also, when we cure tobacco or dry tobacco, we reach temperatures of 165 degrees Fahrenheit. So tremendous amount of airflow and heat, thermal energy capacity in a bulk curing barn. The objective is to collect post-harvest performance information utilizing these bulk curing barns. And once again, we've already got these barns instrumented, or some of these barns instrumented at a given location to collect a lot of different pieces of information, but primarily using these barns as far as drying hemp. You're going to be primarily interested in the temperature and humidity profiles that are used and the material throughput. You know, how many pounds of material is moved through the barn, how many acres are covered, drying time, etc. So I've got a couple of pictures showing the actual barns being loaded, the actual containers or boxes is what we call them. And there's two locations in Johnston County I'll share with you. And this is a long 10-box barn. And here you can see the growers loading approximately a little more than 1,000 pounds of green material. So this is freshly harvested plants. And the variety in this case was Super Haze. The whole plants are loaded in the barn or in the container, and it is sitting in the boxes just like it is growing in the field. The stalk is down in this particular case. Other material handling and loading equipment. And so the other advantage tobacco farmers have as far as growing hemp for the oil extraction is they can utilize a lot of their existing green leaf handling systems. So certainly that can help with labor savings associated with just handling the material. And that's what you see in these pictures, the live bottom trailers, once again, the boxes. They can also run the material up through the green leaf handling system. Forklifts are used certainly extensively with tobacco operations, and here more of the same. But also the grower actually started loading the boxes in the field. So the workers are cutting the materials and the boxes are on these trailers or certainly unloaded off a trailer. But the bottom line is the boxes can be loaded directly in the field, and that certainly would save a step from a handling standpoint. Here's just a close-up shot of showing the boxes in a curing barn. This happens to be a Decloit bulk curing barn, and you see the plants are kind of randomly loaded or oriented, so to speak. Some of the stalks are up, some are down. I've seen a little bit of both, and I don't know that it really matters. Probably it's more common to see the actual stalks pointed up or the stem of the stalk of the plant pointed up. But the other thing to point out is the airflow capacity is very significant in a curing barn. This material is bulked in. We like to refer to as a bulk density, pounds per cubic foot. This is about 5 pounds per cubic foot. Well, the green leaf of tobacco is twice that. It can vary from 10 pounds to as high as 12 or 13 pounds per cubic foot. So the resistance to airflow is very minimal as compared to drying or curing tobacco. This is two tables that summarizes the material handling throughput capacities basically of 2 locations in Johnston County. Is actually the third listed in table 2 down at the bottom from Wilson, but it gives you some idea of the throughput capacity. So the green weight varies anywhere from 9,000 to 11,000 pounds. You can also see the marketed weight material and then the capacity in terms of acres, and certainly that's going to vary with varieties, agronomics, the size of the plants, a number of factors. But you're seeing a single 10-box barn is able to handle anywhere from a half acre to acre and a half of material. And the drying schedule that was followed at this location A, this 4 barns were utilized, was 95 degrees dry bulb and 83-degree wet bulb, which would give them 60%. So with these bulk curing barns, a lot of them have automatic ventilation control, so the grower can pretty accurately and automatically control both temperature and humidity in the barns. The other location took about 4 or 5 days to dry, but he dried at 95 degrees also. Here you can see the throughput and also a little bit of information associated with energy. And compared to a curing tobacco, this is a lot less energy is required. Well, the moisture content of the green leaf of tobacco is about 85 to 90%. When we sampled plants and took initial moisture contents, it would vary anywhere from 60 to 70%. I don't recall seeing anything higher than 70%. So there's a lot less water, and plus there's a lot less material, so a lot less total water that's actually got to be evaporated. And in table 2 is showing one of the locations in Johnston County and then one in Wilson. And in here you get some idea how many acres per barn. Well, these numbers are certainly a little bit less than typically what you would see, because this is not just a long 10-box barn. This average takes into account a lot of different size barns, and not all barns have the same material throughput capacity. It's a different number of boxes, different loading rates on those boxes, different size boxes, etc. But the bottom line is a single barn could handle half acre to an acre plus of material and dry that in 4 or 5 days. A little bit about the hemp drying studies that we're involved in. One was with the North Carolina Department of Agriculture, and the other was through a Pyxis, a private company. But we used the Central Crops Research Station, and they had 4 small curing barns, primarily used to cure tobacco, but they are fractional scale size compared to a conventional barn. But essentially what we're looking at in both studies was the temperature effect on the cannabinoid levels with the NCDA primarily, and they were looking at some other things too, but just from our standpoint, 4 temperatures, 90 degrees, 110, 130, and then ambient conditions. And then the Pyxis study was primary objective was to look at the temperature effect on the decarboxylation effect on the THC acid form to the total THC. And we went to some higher temperatures, 105, 120, 135, and 160. And the material was harvested from an on-farm location, then delivered to the station. And the material was dried in less than 48 hours, the material associated with the Pyxis study. And what this slide is showing is the CBD content, the total CBD, and you see, and what you've got here is you've got a B and an A associated with different temperatures down on the x-axis. The B would be the material levels before drying, and then the A would be for after drying. And so you've got the no heat, the 90 degree, 110, and 130, and certainly you see a temperature effect on the total CBD. You see as you go to higher temperatures, the difference in CBD before and after certainly increases, and that certainly is going the wrong direction. So that certainly emphasizes the point that you want to avoid high temperatures when you're drying hemp, because certainly you're getting paid for this CBD content. The other thing I want to point out is this no heat and 90 degree heat. Well, this was done the first week of October in 2019, where we had ambient temperatures 90, 95 degrees. So it was impossible to maintain 90 degrees in that barn, plus the no heat capacity was. So the bottom line is these two really are at the same temperature. Very difficult to dry it at, very difficult to maintain a low temperature when ambient's 90 or 95. Here's a picture of the study with Pyxis, when the material was harvested on farm and brought to the station. And here you see 10 plants. There's 4 barns, so a total of 40 pounds of green material per barn. And it's just simply randomly loaded, the whole plant. But And this is the data that we received from Pixis. And once again, they're primarily interested in the THC conversion. And you see the barn temperature, 105 up to 160. Moisture content, obviously, as we go to higher temperatures, the moisture content decreased. Little, not a lot of difference in the CBD percentage, certainly some, but once again, more importantly, what they were interested in was the Delta 9 conversion. And certainly you see when you go from 105 dry bulb to 160 drying this material, you've got almost a 3x or a little more than a 3x difference in the Delta 9. So certainly the temperature effect on that conversion of the THCA over to Delta 9. And I think this is the last slide I have. And so certainly and this is conversation once again is related to using curing barns to dry hemp. Your contracting entity and whatever your target market quality requirements are going to affect the drying schedule followed. So whoever your contracting entity, they may have some specifications on what temperatures you dry at. Bulk curing barns may not work well with drying smokable hemp products. My understanding is that smokable hemp is more of a as much a curing process as it is drying. And I have been seeing temperatures certainly do not exceed 90 degrees Fahrenheit, and that may be difficult in a bulk curing barn, particularly with the ambient conditions you may be dealing with. And it may require some dehumidification systems or some other infrastructure may have to be added if you want to use a bulk curing barn for the smokable hemp products. You're going to want to avoid high temperatures for extended periods of time, and certainly less than 105 degrees, and it may be better to stay somewhere between 95 and 100 until we have more information related to the actual, dry material quality. Box loading rates, 1,000 pounds was certainly very common, 1,000 to 1,300 pounds. Are you drying the whole plant, just the branches removed from the stalk? Flowers, obviously, if you're just drying flowers in bulk curing barns, you can cover multiple acres with a single barn. The other thing to certainly keep in mind is ambient air conditions may not be suitable for drying. If you've got high relative humidity, it's going to create an ideal environment for mold growth. So what you may need to do is increase the dry bulb temperature 5 to 10 degrees above ambient so that you increase the water holding capacity or the drying capacity of that air to certainly minimize mold growth. We get some questions about long-term storage of this dried material, and hopefully you don't have to store it for very long. That'd be ideal. But unfortunately, we know that's not always the case. But long-term storage is going to require an environment that you can control both the temperature and humidity, and certainly leaving it in a bulk curing barn will allow you to do that. So with that, I will stop. Certainly, if you have any questions, you can contact me. I can certainly share any information I have with you as needed. So thank you.